Chinese rocket is on its way to the moon with a mission to bring back rock samples back down to Earth.
For decades, the moon has been seen as nothing more than a silent rock in the sky. But what if that quiet surface has been hiding secrets that could change the future of humanity? China's recent lunar missions have uncovered findings that shake the foundations of space exploration, science, and even global power.
We will conduct deep study of these precious lunar samples, and it is for sure we will cooperate with global scientists and organizations on the scientific research.
From strange soil samples to a mineral that could fuel limitless clean energy, the discoveries are staggering.
Chinese ground crews are awaiting the landing of the unmanned mission, and with it, the first lunar samples in more than 45 years.
Joe Rogan just dived into what China really found on the moon.
There was a whole story today about China just landed on the far side of the moon. So they landed a probe over there.
Yeah, they did.
It's just, you know, there was the China-America war on the moon.
And why it could change everything we thought we knew about our place in the universe. The return to the moon. Why China's mission matters. In December 2020, China stunned the world by doing something that had not been achieved in over 40 years. Its Chang'e 5 mission touched down on the moon, collected samples, and safely brought them back to Earth.
China has managed to bring moon rocks back to Earth, the first mission to do so in over 40 years.
The last time this had been done was during the Cold War, when the United States and the Soviet Union were locked in a race for space dominance. After the Apollo missions and the Soviet Luna program ended, humanity's contact with the moon became limited to orbiters and rovers. No country had attempted a return mission to physically bring back pieces of the moon until China. The Chang'e 5 probe was a masterpiece of modern engineering. It landed in a region called Oceanus Procellarum, also known as the Ocean of Storms. When the lander drilled into the moon's surface, it carefully extracted both soil and rock fragments. After a complex transfer process involving an ascent vehicle, an orbiter, and a return capsule, the mission delivered a precious cargo back to Earth, 1,731 grams of lunar material. While this might sound small in weight, the scientific value was immeasurable. Each grain of dust carried clues to the moon's volcanic history, its chemical composition, and even hints about resources that could one day power human civilization. By succeeding in this mission, China became only the third nation in history to bring lunar samples home. It now stood alongside the United States and the Soviet Union in an elite club of space powers. Yet unlike the space race of the past, this was not just about prestige. Experts pointed out that the 2020s were shaping up to be less about planting flags and more about securing resources. In this sense, Chang'e 5 was not only a scientific victory, but also a signal of competition that extended beyond Earth's borders. Joe Rogan was quick to note the symbolic weight of the mission. China had demonstrated not just the ability to land on the moon, but also to return materials across nearly 400,000 kilometers of space. It was proof of long-term planning, massive investment, and growing ambition. While NASA was preparing its Artemis program, China was showing it could leap forward on its own terms. Plus, Chang'e 5 set the stage for discoveries that would cut across science, energy, and geopolitics. The samples were unlike anything humanity had studied in decades. And when scientists began to analyze them, they realized they were not simply looking at dust from the past. They were staring at the future. So what exactly was inside these lunar samples that sparked such curiosity and set researchers racing for answers? Secrets hidden in lunar dust. The soil of the moon, known as regolith, is more than just gray dirt. To scientists, it is a library of time, preserving events that Earth's shifting atmosphere and tectonic plates have long erased. Unlike Earth, the Moon has no air, no wind, and no protective shield. For billions of years, it has been exposed directly to solar winds and cosmic radiation. Every collision, every eruption, and every storm of particles has been set into its dust, leaving behind a record untouched by weather or erosion. This means each tiny grain is a fossil of cosmic history. When scientists first sifted through the material, they found something remarkable. Much of the dust was made of fine particles shaped by both volcanic flows and endless meteorite bombardment. Each particle carried scars of violent impacts. Some were jagged, like shattered glass. Others were smooth and rounded, the result of having been melted and cooled in explosive eruptions. It was as though the ground itself was a battlefield, storing memories of fire and stone. Among the most surprising finds were tiny glass beads, and these are not ordinary fragments. They had formed during ancient volcanic eruptions, when fountains of lava spewed into space and instantly cooled in the vacuum. What made these beads even more extraordinary was what they carried inside. Inside the grains, scientists detected hints of hydrogen isotopes. These are the same kinds of particles that can theoretically fuel space propulsion systems. If such isotopes could be extracted at scale, the Moon might not just be a graveyard of the past, but a fuel station for the future. Imagine spacecraft refueling directly from lunar soil before heading deeper into the solar system. The idea, once science fiction, could become a real possibility. To Joe Rogan, this was a startling realization. Lunar dust was no longer just a scientific curiosity. It was both a diary of cosmic history and a potential key to solving one of humanity's greatest challenges, which is sustainable energy beyond Earth. China's Chang'e 5 samples were rewriting the story of the Moon, and with it, humanity's role in space exploration. To grasp how China managed to reach these groundbreaking insights, we need to look closely at how its lunar exploration strategy differs from past missions and why that difference matters. A different strategy: China's precision science. Unlike the earlier Apollo missions that gathered rocks with human hands, China's Chang'e 5 approached the Moon like a surgeon. This was not a race for glory, but a quiet, deliberate effort to probe deeper and more carefully than anyone had done before. The spacecraft's robotic arm wasn't just scooping dust. It drilled nearly 2 meters into the ground, reaching layers of lunar soil that had never been exposed to solar radiation or micrometeorite bombardment. These samples, untouched for billions of years, held secrets that could rewrite what we thought we knew about the Moon's history. The choice of landing site added to the intrigue. While NASA's Apollo missions focused on ancient highlands more than 3 billion years old, China set its sights on a region shaped by volcanic activity just 2 billion years ago. This made the soil much younger than the Apollo samples, offering a missing puzzle piece in the Moon's geological timeline. Scientists around the world were watching closely. If these rocks told a different story, it would mean our understanding of how the Moon evolved was incomplete all along. The strategy extended beyond the landing itself. Chang'e 5 was designed not only to collect samples, but to return them to Earth for exhaustive testing in Chinese laboratories. Researchers employed state-of-the-art tools like spectroscopy, electron microscopy, and ion beam analysis, methods that could study the tiniest chemical fingerprints. Nothing would be rushed. Every fragment would be cross-checked against international lunar data gathered over decades. And it was here, in this slow, painstaking process, that rumors began to ripple through the global science community. Joe Rogan pointed out on his podcast that some researchers were saying China's methodical approach could lead to findings no one had ever seen before. Not just confirming old theories, but possibly revealing something entirely new, hidden in plain sight beneath the lunar surface. The secrecy surrounding China's space program only added to the suspense. Updates were released in fragments, leaving scientists and enthusiasts across the globe to speculate. What were they seeing under their microscopes? Was there evidence of resources that could change the balance of power on Earth? Or perhaps clues about the moon's mysterious volcanic past that had long been debated but never resolved? For months, scientists remained silent, analyzing, double-checking, and running data through every available test. Unlike the Apollo era, where political pressure demanded quick results, China was in no hurry. They wanted accuracy, they wanted certainty, and above all, they wanted impact. Then, at last, the cautious hints turned into open excitement. Researchers began to confirm what few had dared to imagine. The lunar rocks carried by Chang'e 5 weren't barren. They contained something that proved that the moon might not be as dry and lifeless as once thought. Now the question became obvious. What else had China uncovered in those carefully guarded samples? The discovery of lunar water. For decades, scientists debated whether the moon was completely dry. Apollo astronauts in the 1970s brought back samples that seemed bone dry, leading many to conclude that water simply could not survive on the lunar surface. The sun's relentless radiation and the moon's lack of atmosphere appeared to rule out the possibility. Yet some researchers continued to suspect there was more to the story. China's Chang'e 5 mission would provide the clearest evidence yet. When scientists began analyzing the samples returned in 2020, they noticed something unusual. Microscopic volcanic glass beads, tiny fragments created billions of years ago during ancient lunar eruptions, contained traces of water molecules locked inside. These were not lakes or ice sheets, but individual molecules trapped within the very structure of lunar minerals. The discovery was small in scale, but its implications were massive. Further analysis showed that these beads had acted like natural sponges. Over time, hydrogen atoms carried by the solar wind bombarded the lunar surface. These hydrogen particles embedded themselves into the glass, where they combined with oxygen in the minerals to form hydroxyl and water molecules. This meant the moon was not simply a dead, dry rock, but a body constantly interacting with space in surprising ways. The most groundbreaking part was scale. If even tiny fractions of water existed in millions upon millions of glass beads scattered across the surface, scientists estimated that the moon could hold hundreds of billions of tons of water reserves. This wasn't just a scientific curiosity, but a game-changer for humanity's future in space. Water is the foundation of survival. For astronauts on the moon, it could mean drinking water without endless resupply missions from Earth. But the possibilities went far beyond hydration. Water could be split into its components: oxygen for breathing and hydrogen for rocket fuel. A lunar base could essentially mine its own resources, dramatically lowering costs for long-term missions. The idea of refueling stations on the moon began to sound less like science fiction and more like an engineering challenge. A steady supply of hydrogen and oxygen could transform the moon into a launch pad for deeper exploration. Missions to Mars and beyond would no longer have to carry all their fuel from Earth. Instead, they could top up at a lunar outpost, cutting costs and risks. Equally remarkable was what this revealed about planetary science. If solar wind could implant hydrogen and create water on the moon, then similar processes might be happening on asteroids, Mercury, or even other airless worlds. The very mechanics of how water forms in space had to be reconsidered. The discovery was rewriting textbooks while opening new doors for exploration. For China, this was also a powerful demonstration of its growing leadership in space exploration. While other nations were still theorizing about the existence of lunar water, Chang'e 5 had delivered physical proof. In fact, the samples provided some of the most direct evidence ever found. It was no longer a question of if there was water, but how much and how usable. But as Joe Rogan highlighted in Shock, what China uncovered next would make even lunar water seem ordinary. Because, as exciting as the water discovery was, it was only a step towards something even more extraordinary. Hidden within the same set of samples, researchers identified not just water, but something entirely new. This was an unknown mineral that could hold the key to solving humanity's greatest energy challenge. A mineral never seen before. For decades, scientists studying lunar rocks had cataloged countless familiar compounds, from silicates to trace metals. But inside the samples that Chang'e 5 ferried back to Earth, researchers spotted something that did not match anything in the geological record. Under the microscope, they found a crystal structure so sharp and precise that it stood out from the dust and shattered fragments around it. It was not simply unusual, it was entirely new. The team confirmed their discovery after months of cross-checking. The mineral was named Change Site Y, a tribute to the Chang'e lunar mission that had made its collection possible. With that name, China joined an elite club of nations whose space programs had uncovered brand new minerals beyond Earth. Only 5 entirely new minerals had been recorded from the Moon in human history, all by earlier Apollo and Soviet missions. This marked the 6th ever identified and the first claimed by China. What made Change Site Y remarkable was its composition. Unlike the common lunar basalts or glassy beads produced by meteor impacts, this crystal was phosphate-based. Phosphates on Earth are tied to everything from agriculture to electronics, but the Moon had yielded one that seemed to grow under conditions impossible to replicate in Earth's natural environments. Its atomic structure was arranged with near-perfect symmetry, almost like it had been sculpted, not by human hands, but by the unique pressures, temperatures, and cosmic radiation of the lunar surface. Joe Rogan remarked on his podcast that this was the moment the Moon shifted from being a distant gray sphere to a treasure chest of untapped potential. He pointed out that when a nation unearths something never before seen in nature, it changes not only science textbooks, but also global politics. Suddenly, the Moon was not just about footprints and flags, about resources that could fuel the next wave of human progress. Scientists highlighted how rare it was to isolate such a pristine crystal. Most lunar minerals are damaged by bombardment from micrometeorites or altered during re-entry to Earth. Yet this one survived intact, locked in its glass-like form, as if nature had been preserving it for discovery. Its clarity made it easy to study, giving researchers an unprecedented look into how lunar chemistry diverges from Earth's. The announcement stirred quiet but intense discussions in scientific circles. If such a mineral could exist undetected until now, what else might lie hidden beneath the regolith? Was the Moon still holding a library of undiscovered materials that could redefine how humanity approached technology and energy? But the shocking thing was that if harnessed, lunar minerals like Changeasite Y could power the most unexpected things on Earth. The shocking reveal: fuel for fusion. When Chinese scientists placed the lunar samples under their electron microscopes, they weren't expecting a world-shifting discovery. Changeosite, Y, wasn't just a geological novelty. Its atomic structure hinted at energy applications far beyond Earth. At first, the announcement sounded like just another scientific curiosity. A new mineral was interesting, yes, but hardly world-changing. Yet as the analysis deepened, the implications began to shake the scientific community. Researchers noticed its unique ability to trap and interact with helium isotopes, particularly helium-3, which is an element that has haunted the imagination of scientists for decades. This was the bridge between a dry mineral sample and the biggest dream in modern science: nuclear fusion. Nuclear fusion is the energy process that powers the sun. Instead of splitting heavy atoms like uranium, as nuclear fission does, fusion merges light nuclei together. When hydrogen atoms fuse, they release staggering amounts of clean energy, with no greenhouse gases and almost no radioactive waste. For nearly 70 years, physicists have been chasing this dream, calling it the holy grail of power. The problem has always been fuel. On Earth, fusion reactors demand rare isotopes like tritium, which are expensive and unstable. But helium-3, a lighter isotope, could make the process vastly cleaner and more efficient. And that is exactly what the Moon holds in abundance, buried in its dust by billions of years of solar winds. Helium-3 is almost absent on Earth. Our atmosphere and magnetic field shield the planet from the solar particles that deposit it. But the airless, unprotected Moon has been soaking up helium-3 for eons. Estimates suggest there could be over 1 million metric tons of it scattered in the lunar regolith. If just 1 ton were brought back and used in a fusion reactor, it could generate enough energy to power an entire city for years. Now, add the fact that Changesite, Y, appeared capable of storing or stabilizing helium-3, and suddenly, the mineral became more than a rock, but a key to unlocking limitless, clean, near-eternal power. But while independent experts agreed that the find was exciting, they also stressed that any energy link is still a long road. The science is real. The timeline is uncertain because fusion is the process that powers the sun. Very light atoms are pressed together until they join into a heavier atom. When that happens, a huge amount of energy is released. If humans can control fusion on Earth, power would be clean at the point of use and very high yield. It would also avoid the long-lived waste linked to fission power. That is why fusion is often called the ultimate energy goal. The return of fresh lunar samples, plus the careful mapping of minerals like Changesite, JRE, made people ask new questions. Could we one day find, map, and process the right places on the Moon for useful fuel cycles? It is important to be clear that no reactor today runs on helium-3. Most major fusion projects focus on deuterium-tritium fuel. Helium-3 fuel would need much higher temperatures and new reactor designs. Mining helium-3 on the Moon would also be a massive job. Concentrations are expected to be very low, which means a huge amount of soil would need to be heated and processed. The energy and logistics required are not solved yet. But still, the possibility was enough. Changesite, Y, is a real mineral with clear lab data. Fusion is a real field with steady progress, and helium-3 fuel was now looking like a serious idea. The bridge between these points is long, but each new sample and each new analysis makes the map clearer. A single ton of helium-3 could possibly provide as much energy as 15 million barrels of oil. Fusion energy could end reliance on fossil fuels and reverse the global energy crisis. Joe Rogan's take on the discovery captured the unease perfectly. He said it reframed the entire space race. The Moon was no longer about exploration, no longer about planting flags and testing rovers. It was now about energy supremacy, about who could harness the first fuel that might truly end the world's dependence on oil, coal, or uranium. Whoever mastered lunar helium-3, with change site Oekai as the tool, would not just lead in science, but dominate the future of global energy. The stakes had never been higher. The shock spread quickly through the scientific community. Nuclear engineers speculated whether this discovery might finally accelerate progress toward working fusion reactors. The fusion dream had always seemed distant, like science fiction. But the idea that the raw materials might already be within reach on a celestial body only 3 days away changed everything. If change site Y really was the missing piece, then humanity's future energy source might not come from oil fields or nuclear plants, but from the gray plains of the moon. And that realization ignited a new sense of urgency. The cautious exploration of space could give way to something far more aggressive. With such a resource at stake, global powers could begin to look at the moon through new, sharper eyes. Because if the moon might shape the future of energy, even as a possibility, then control of landing sites, sample rights, and mining rules becomes more than science. It becomes strategy, and that is where geopolitics begins. The geopolitics of lunar gold. The revelation that the moon holds resources capable of fueling nuclear fusion did not stay in the pages of science journals. It rippled into strategy papers, defense meetings, and long-term energy forecasts. Suddenly, the moon was no longer just an outpost of exploration. It was the potential Saudi Arabia of space, holding the raw material for a new energy age. And every major space power began paying closer attention. The United States has the Artemis program, a multi-phase effort not only to return astronauts but to build a permanent presence on the lunar surface. China, fresh off the success of its Chang'e missions, has already announced plans for a lunar research station in the 2030s. India has advanced its Chandrayaan program, while Russia, despite setbacks, is still pursuing its Luna series. The European Space Agency continues to push the concept of an international lunar village. These aren't just science projects anymore. Each of them now carries the weight of economic and strategic ambition. Policy experts have noted a clear shift. Space programs are aligning with resource strategies. Where Apollo sought prestige and Cold War bragging rights, Artemis and Chang'e point to control of resources and infrastructure. Analysts warn that if this trajectory continues, we could see the moon divided into zones of influence, not by law, but by who gets there first and stays. The challenge is that the rules governing space are still frozen in the 1960s. The Outer Space Treaty of 1967 bans nations from claiming celestial bodies, but it says nothing about companies or the gray area of non-sovereign use. There is no enforcement mechanism to stop a nation from planting long-term infrastructure around a resource-rich area and effectively controlling it. Legal scholars argue that this gap is the perfect recipe for conflict. The stakes are high enough that military planners are now quietly paying attention. Both US and Chinese defense documents reference CES lunar space, which is the region between Earth and the Moon, as an emerging domain of national security. Control of this space means control of the pathways to lunar resources. If lunar bases and mining systems are ever built, they could become strategic targets, even in peacetime, vulnerable to sabotage, hacking, or orbital interference. While no weapons have been placed on the moon, the possibility lurks in classified discussions. Diplomatic attempts to prevent this split are already showing cracks. The Artemis Accords, promoted by the United States as a framework for peaceful lunar activity, have been signed by over 24 nations. But some countries have declined to join, pursuing their own legal and operational interpretations. This sets the stage for competing governance systems, with alliances forming on both sides. As a result, experts are now beginning to warn of potential disputes over mining zones near the lunar poles, where water ice and helium deposits are richest. They caution about clashes over launch schedules, satellite positioning, or even cyber attacks against mission infrastructure. In these simulations, the moon isn't just a scientific frontier, but the first real territory where Earth's rivalries spill into another world. For Joe Rogan, the unsettling reality is stark. The moon may not remain a symbol of human unity or wonder. Instead, it risks becoming a high-stakes prize and a new kind of battlefield where the future of energy and the balance of global power are decided. But at the same time, there is awe, because beneath all the danger, the moon offers something extraordinary. The possibility of an energy revolution that could sustain humanity for centuries. In this framing, China's discovery of Change Site Y is more than science. It is a glimpse of how the moon could become not just humanity's next step, but the very key to its survival. What do you think about this discovery? Feel free to share your thoughts with us in the comments section. Want more videos like this? Then subscribe to the channel for more eye-opening stories. Thank you so much for staying with us till the end. See you in the next video.